All right, so here we're going to be starting. We're going to be doing properties of logarithmic functions. And so properties of log is just another set of laws. Laws of logs, properties of laws, right? This is just going to help us get started before we do equations with all of this. And so once again, we're going to declare that a is greater than 0. So all my logs base a's are always going to be greater than 0. The reason is we get too many problems elsewise. We're going to let a, b, and c, or capital A, capital B, and capital C, be all real numbers, where a is positive and b is positive. Now we're only going to do, we're just going to, just for the sake of simplicity, right? Because if I can't have a log of a negative number. Remember how the graph of the log looks? We can't have negative numbers. And so here, if we have log of negative numbers, these become undefined. And so we can't have that. So A and B. C, however, since it's an exponent and a multiplication, is allowed to be negative. Okay, so let's just go over it. So if I have log base A of A times B is the same thing as log base A plus the log base A of B. So here I can take multiplication inside the log, split it to be addition outside the log. And this comes from the fact that if I have exponents, if I add up two exponents, it's the same thing as multiplying them. The translation isn't as direct, so I won't show you the direct translation, but it's the same concept. And here, if I divided two exponents, it's the same thing as minusing the exponents. So that's where this comes from a little bit. Bigly, I'm being a little bit hand wavy when I say that. And so here, a minus b is this. One of the things you can do, and we'll just write it here, is log base a. If you have a, b, let's just add d and e, you can write this as log of a plus log of d minus log of d minus log of e. And what do I mean by that? If it's on the top, if it's on the numerator, you can just say positive, and if it's on the bottom, you can just say negative. Okay, and so these two rules kind of imply this, right? And we'll use this later. We'll use this later to make our lives easier. And so you could use the rule one at a time. You could split it and then do the negatives, but that's not necessary. Just know if it's on the top or if it's multiplied by each other or on a numerator, you can just split it with addition, so make it positive. And if it's on the bottom, make it negative. And the reason that is let me just do one other thing, because this implies, the log and this. So let me do this one. So the log of a to the c is the same thing as c times log of a. Okay. And this deals with multiplication. And so here, if I have log of a times b, this is the same as log of a to the b minus 1, which is the same thing as log of a, my little a's, of a, plus log of b minus 1. And this thing is the same thing as log of a plus, or minus, log of b. And so here, we can kind of see that using this rule, we can actually produce the middle one. And so the nice thing here, if it's, once again, all these rules, or these two rules, can be really simplified to, if it's on the top, make it positive, if it's on the bottom, make it negative. I mean, it's fairly simple that way. All right, so let's go ahead and do this. So evaluate the following. So we're going to be using these rules to evaluate these logs. And we've learned how to evaluate some logs, but now let's actually do this one. So here, let me ask the chat the question, 2 raised to what power is 4? So log base 2 of 4 is what? What does this evaluate to? Just this part. See if you remember how to do this. And ignore the rest for a second. Pretend it didn't exist. Log of 2, log base 2 of 4 is equal to what? And it's the same thing of asking, remember logs ask the question, a raised to what power is x. So here if I have a log base a of x, a raised to what power is x? So here, yeah, 2, right? So 2 raised to the second power gives us 4. So this is 2. Go ahead and get rid of all this. And 2 raised to what power is 8? Log base 2 raised to what power is 8? See if you give me in chat. 3, yeah. And so here we have 2 plus 3 is equal to 5. And so here we evaluated this. Another way of evaluating it is using this rule up here, and I could write log of 2 of 4 times 8, right? So here I can do, I add them up, it's the same thing as multiplying it. So 4 times 8, which is log of 2 of 32. Well, 2 to what power is 32? Well, the answer is 5. And so here, either way works. You can evaluate it directly, like we did here, and get 5, or we could use our rule up here to put it together. Now, in this case, I have log base 2 of 80. 2 raised to what power is 80? Well, you don't know that, right? And the same thing, you don't know what this is, right? 2 to what power is 5? You could type it in a calculator and get answers, and you'll get the right answer. But let's do it by hand first. All right, so here we have 2 raised to this, but here we're going to use this rule, right? And notice sometimes for these rules, we're going to want to use this to put it in this form, and sometimes we're going to want this to put it into this form. So you'll go back and forth to which way you want to transform it. So here, I'm just going to do this division rule, right? So I have a log minus a log, right? And so I'll have log base 2 of 80 over 5, right? Because here, minusing the 2 gives us 80 over 5. So here I have log base 2 of 80 over 5 is 16. 2 to what power is 16? Do you guys know? 2 to log is 4. Yeah, so here it has 4. Okay. All right, so let's look at this one. Here, we could compute it directly, and honestly, that's what I would have done, right? So log base 2 of 8. Log base 2 of 8, we know what that is, so that's 3, so we have 3. And this is equal to -1. Or we could have computed it using our rules, and so let's just use our rules for a second. So this is 8 to the -1/3 power. 8 to the -1/3 power is log base 2 of 1 over the cubic root, the cubic root of 8. And the cubic root of 8, of course, is 2. So we have, log base 2 of a half. And 2 raised to what power is a half? Well, the answer here is the same here, -1. Okay. And so we're going to be using these rules in order to solve these. And so eventually we want to solve equations, right? That's what we want to do. So we're going to be doing we're going to do 2 things. We're going to expand it. So we're going to, by expanding, what that means is usually going from this side to this side. So writing out more terms. That's what expansion means, is write out all the terms. And combined means is collecting as many terms as possible. So here, for this log base 5, we're going to have log of 5 of 6 plus log of 5 of x plus log of 5 of y. Now, technically, if we're going to use our rules directly, we should have 6 times x times y, and then the next step would have been to split it apart, but that's a little too pedantic even for me. So remember just the common rule. If you see it on the top, make it positive. If you see it on the bottom, make it negative. So here, we're going to do this again. And so here we'll have ln of x cubed plus ln of y squared. So here we have multiplication. We're going to split it into addition, right? Multiplication becomes addition. Then here, powers become multiplication, right? So powers become, you multiply up front. So here we can pull the 3 out front. That's why we use logs to solve things, is we can get rid of exponents. and pull out a 2. And there we go. And so this is a completely expanded. Okay. Here we're going to use the rule I taught you. So here we have ln of x cubed. This is on the bottom, so we're going to say minus ln of y, square root of y. This is also on the bottom, so it'll be minus ln of z squared. Okay, so remember, if it's on the top, have a positive. If it's on the bottom, have a negative. Okay. And actually, let me solve this for you twice. I'll solve this twice for you. And then the next thing, we're just going to pull out our exponents. We're going to pull out our exponent and pull out our exponent. So the exponent here is 3. So we have 3 ln of x minus the exponent here, square root, is the same thing as a half, if you remember. So this is ln of y. And here, we just pull this out. So it'll be minus 2 ln of z. So notice real quick, let me do something. Let me write this as ln of x cubed minus y to the minus half minus z to the minus 2. Notice here, all I'm doing is just moving. So here I have divided by a half, but I can move it to the top and write minus a half, and then here I can move this up. And then when I split this apart, it'd be x cubed. It'd be x cubed plus y to the negative half plus y to the z to the minus 2. And then when I pulled it out, you get the same answer. Okay? So either way, whatever way makes sense for you, go ahead and try it that way. All right. Any questions on anything from example 1 or example 2 before I go on? It might seem a little esoteric for a second, but once you start doing the homework, it'll start to click. Hopefully. There's a very old saying, math's not a spectator sport. You're not going to learn by watching me, but let me walk you through what to do, and then you'll work on the homework and figure it out. So no questions from the first two? Okay, so let's do our example 3. And we'll go from there. All right, so I'm going to do A, C, and D, and I'll have you guys do B. So let me start with D. Let's actually start with, let's start with A, we'll go to D, and then we'll do C. Okay? All right, so here at A, I want to combine. And so basically, I'm going to be using these rules to make it into this. So I'm going this way. So here, I'm going to put the 4 in. And so when it says combine, I'm going to put the 4 into the x. So it'll be x to the 4th plus ln. I'm going to put the 2, make it an exponent now. And so when we expand, we're trying to write out the terms as many ways as possible. When we combine, we're going to try to squish it all back together. So here we have addition, and addition turns into multiplication. So here I have x to the 4th. X plus 1 squared. Okay, so here we just multiply these two, and we're done. Here, notice here, before we do anything, that I have 2 log of x plus 1. Whatever this is just some number. Remember, log of x plus 1 is a number. I don't know what it is, but it's a number, right? And I minus a log of an x plus 1, or minus log base 7 of x plus 1. So here, I could just write this as log of 7 x plus 1 plus 3 log of 7. Okay? So I could do this, right? And actually, if I was doing it, that's what I would do, right? I'd put it together first. But just for the sake of learning, let's not do that. Let's just not do that for the sake of learning. Let's just put it all together. And so here we're going to plug in I'm going to pull in all my factors. And so here I'll have log base 7 of x plus 1 squared plus, I'll pull in my negatives. I like to pull in my negatives. So x plus 1 to the minus 1 power. Let me actually not pull in the negatives for you guys. Let's make this as easy as possible. I'll pull in, so plus log of 7x plus 3 cubed. All right, so we have it at this point. So we have log, and so we pulled in all our exponents. So if we had a factor out point, we pulled them all in. At this point, we're going to write it all as multiplication now. So it'll be log of 7, and here we'll have x plus 2, or x plus 1 squared on top, x plus 3 cubed, and then on the bottom, since we have a negative, we'll have an x plus 1. And here we can cancel off one of these with one of those, and we would have gotten the same answer we got before. Okay, which is equal to the log base 7 of x plus 1 times x plus 3 cubed. Okay. All right. So let's do this one together. So notice for this one, the bases are different. So we have a 7, we have a 9, we have a this. So we can pull in, so I can log base 5 of x squared. I can pull in log base 7. There is no exponent to pull in for this one, so we just leave it. And here, I can leave this as minus. In this case, I'll go ahead and pull in the negative. I'll pull in the negative for this case. 9 x minus x plus 3 to the minus 3. Okay. But notice since this is a 5, this is a 7, this is a 9, our rules only work if A's matches, right? A and A, right? A. If they don't have the same base, we cannot use this. And so we're done. We're done. And why? We have different bases. We have different bases. Okay, so since we have different bases, we're done. All right. So you see me do it once, twice, 3 times. And so this is actually the simplest one in my opinion, right? Because it's all just nice, clean variables. So go ahead and try B. Try B and give me the answer in chat and see what you guys get. Okay? Pull in your exponents. And after you pull in your exponents, combined it, right? Either put it on top if it's positive or put it on the bottom if it's negative. Or if you made it all positive by pulling in the negative, and this will be pulling in the negative 3, just retranslate it as once you get it in. Okay, so go ahead and do that, and I'll be back in 1 second. As you guys work through that, it'll take a second. Got something sticking out of their mouth. They're gels. Gels. Your butt's falling off, dog. All right, so we got one answer. Let's see if we get one more, and then we'll go ahead and do it. Apparently it's Puppo's sleepy time. I brought him in from out back, and they just both curled up in my bed. It's like, yep, it's nighty-night time. Which is good, because last class they were just trying to destroy everything. All right, if I get one more answer, I'll go ahead and work through it. I do want you guys to try it, and if you get stuck, let me know where you get stuck at. All right, so, okay, so I moved it forward. Okay, so let's finish this. All right, so the first thing we're going to do is pull in all our exponents. We're going to pull this in, we're going to pull this in, and leave this here. So we'll have ln of y minus ln of, oh, forgot my 4, x cubed plus, let me pull in the negative. I like pulling in the negatives. Ln of z. And then here, this is addition, addition, addition. So this is ln of y to the 4th, x to the minus 3rd, z. And then here, if I just write it as, I think your book's going to want you to write it always as y z over x cubed. Make that look like a cube. There we go. I think your book always wants it in this form. Okay. And so that's how you do these. I'll leave that up for a second. And then I'll switch to the last page. The last page is how come we don't add the C? Oh. So notice here, if I have addition between my logs, that becomes multiplication inside the log. And so here, let me actually do this as, let me just do this one as 2 different steps real quick. So here, if I add these 2 together, I'll have ln of y 4th x minus cube plus ln of z. So here, the 2 additions become multiplication inside. And then this is still addition, so this becomes multiplication inside. So this is equal to ln of y to the 4th, x to the minus 3rd, z. Okay? Yeah, so technically what we're doing is we do these 2, put it together, and then we do these 2, put it together, but no one ever does it that way, ever. But I think I probably should have shown you at least once by now, so I'll repent for my academic sins and show you. Okay. So usually for when it says combined, you're going to plug in, you're going to pull in your exponents and then just shift stuff up and down. All right, so let's do the last set real quick. So this says change the base formula. So usually when you have an old calculator, you have your old little graphing calculator, you're going to have 2 buttons. You're going to have a log button and you're going to have an ln button, right? And then you have all your other buttons, right? But you won't have log base 3, right? And what happens is you don't need it. So log base b of x is the same thing as log base a of x divided by log base a of b. And what we used to do, at least when I did this in high school and everything, and in college, I had to type in, I used natural log, so I did ln of 6 over ln of 3. So b on the base is on the bottom, what x is on top. So here, if I want to find what log base 3 of this is what I typed in a calculator. I crunch through the numbers and I get 1.63. Some people like to use log, so you can use log base. I can use log of 20, so whatever, and then the base, and just divide by your base, so log of 7. Crunch that through a calculator, you get 1.487. But I always used log ln. It just was easier and more accessible on the calculator I was using. Okay. And so I used to teach this to you in case that way you learned how to do this. But what is our calculator for this class? Calculator for this class is Wolfram Alpha, right? They should pay me, but they don't. It's like a YouTube video. This video is sponsored by Wolfram Alpha. Upgrade to Pro for the mere price of who knows what. Right? You don't need it. The free version works great. And so here, when we type in log, and so let's just type in each of these logs real quick. So here we'll type in log base 3. So log base, and you just you do shift minus, which gives you the underscore 3. And then you put in parentheses 6, and it should, with its little print, show you that you've actually typed it in correctly. This is what it's doing. It's the natural log, right? Where ln's a natural log. So this is actually what this is doing, right? To do this, and it crunches out this number, right? And here you can do ln base 7 20. There's our other one. So log base 7 of 20. And let me do something that's, and then if you have a larger, say 74 of 20,000, that's not 20,000, 20,000, you'll have to put parentheses around your underscore, okay? And then here you can this, and you see that this is correct, and you get the decimal approximation. So this is what you're doing. So one last thing before we call it, before I show you the homework. And so hold on, let me just go ahead and, no, I don't want to put the star yet. So we'll type in log books, or logarithm books. I have books twice, don't I? Books. Okay, images. Yeah. So what you used to have to do way back in the day is you had these books of the logs, right? And you just, it'd be, here's the base, and you just looked up numbers, right? And it's just these huge tables of logs, right? And you had these little books that was nothing more than equations. It's like, this is a whole book, and all it is numbers for this. Welcome to Life Before Computers. This is how you did logs. Be glad you're not doing that. Okay. All right, so let me put a big fat star. Not you.